Now in this video, we're going to take up one more problem on shaft. The problem number 13. It reads as a hollow shaft having internal diameter 40% of its external diameter transmits 562.5 kilowatt power at 100 rpm. Determine the internal and external diameter of the shaft if the shear stress is not to exceed 60 Newton per mm square and the twist in a length of 2.5 meters should not exceed 1.3 degrees. The maximum torque being 25% greater than mean. The modulus of rigidity equals 9 into 10 to the power of 4 Newton per mm square. This has been asked two times. One it is in June, July 2009 and the other one is in June, July 2015. So now how to solve this problem? So he has given the internal diameter is 40% of external diameter, that means 0.4 into d naught. So capital N is 562.5 kilowatt and small n is 100 rpm. So shear stress is not to exceed 60 Newton per mm square and the twist, that is twist in length of 2.5 meters. So length is 2.5 meters and should not exceed 1.3 degrees. So theta, that is 1.3 into pi by 180 in terms of radians. And the maximum torque T max is 1.25 times the greater than mean, 1.25 times T mean. And the modulus of rigidity G will be equal to 9 into 10 to the power of 4 Newton per mm square. So what we want is power transmitted by the shaft, capital N, will be equal to 2 pi N into T mean divided by 60,000 kilowatts. So substitute the values. N will be equal to 562.5, which will be equal to 2 pi into 100. So that is 100 rpm into T mean divided by 60,000. Therefore, the mean torque T mean will be equal to 53,714.8 Newton meters. So convert that into T max, which will be T max is 1.25 times the T mean, which is on substitution, which is 1.25 into 537, 14.8. So then you are going to get it as 671.43.5 Newton meter. So convert that into mm, which will be equal to 671.43.5 into 10 to the power of 3 Newton mm. So what is the diameter of the hollow shaft based on strength? So that will be equal to T by J equals tau by R naught. That is T will be equal to tau into Jp by R naught, which will be equal to pi by 16 into d naught to the power of 4 minus di to the power of 4 divided by d naught into tau. Now you substitute the values, that is pi by 16 into taking the common factor, which is d naught to the power of 4 into 1 minus di by d naught whole to the power of 4 by d naught. So d naught will going to be get cancels, which will be equal to pi by 16 into d naught cube into 1 minus di by d naught whole to the power of 4 into tau. So substitute the values. Now the torque is 671.43.5 into 10 to the power of 3, which will be equal to pi by 16 into d naught cube into di by d naught equals 0.4. So into 1 minus 0.4 to the power of 4 into 60. So we're going to get outer diameter of the hollow shaft, which will be d naught, which is equal to 180.2 mm. So the diameter of the hollow shaft based on the rigidity, that is the torsional rigidity, which is G into theta by L, will be equal to T by Jp. So you substitute the values. So torque is 671.43.5 into 10 to the power of 3 divided by Jp is pi by 32 into d naught to the power of 4 into 1 minus 0.4 to the power of 4, close the bracket. That will be equal to 9 into G, 9 into 10 to the power of 4 into theta is 1.3 into pi by 180 divided by the length is 2.5 meters, which is 2500 mm. So on simplification, the outer diameter of the hollow shaft d naught will be equal to 171.2. Yeah, ma'am. Comparing these two values of the outer diameter of the hollow shaft by strength and also outer diameter of the hollow shaft by torsional rigidity. So you're going to get D naught is the one which is hollow shaft. Outer diameter of the hollow shaft based on the strength is higher value. So adopt the higher value, which is D naught will be equal to 180.2. So the permissible outer diameter is bigger among the two values. So therefore, permissible outer diameter D naught will be equal to 180.2. So the permissible inner diameter DI will be equal to zero point 0.4 into D naught, which will be equal to 0.4 into 180.2, which will be equal to 72.08. So this is how you will be able to solve this particular problem. Thank you.